I am Dirk Müller. I'm with Coherent. And Coherent sees itself as a photonics solutions provider. So we provide a whole different array of different components and lasers, as well as up to subsystems and turnkey systems for photonics industry. And we see ourselves acting in 4 different market segments. That's how we view the world, in these 4 segments. And that's precision manufacturing, microelectronics, anything that would go into a mobile device, for example, bioinstrumentation, life sciences, as well as aerospace and defense. And 3 of these areas actually touch on quantum technology. The one that doesn't perhaps is the precision manufacturing. And Coherent has been active in the quantum community for quite some time. So we have a number of different laser systems that serve the quantum community. And 5 minutes is too short to talk about all of them, but I want to highlight a few here and then go into depth on one specific one. So these are some examples of lasers from Coherent that are currently being used for quantum technology. The Paladin is quasi-CW laser that goes up to several watts at 355. And it finds mostly applications in ion trapping, for example. Many of you know about stabilized lasers that have in the heart of it tapered amplifier. So it's a diode that's amplified with a tapered amplifier. We oftentimes are actually the source of those tapered amplifiers that you find in other vendors' laser systems. Then we have a Mephisto, that's a CW, very stable laser. It is fixed in wavelength, but it has very high power. And it's been used, for example, in some of the gravitational wave experiments that you might have seen in the news. And another category is the diodes and volume bright gratings that we sell. These are more the component level, and they have been purchased by customers who are doing quantum science. So I could talk about any of these in detail, but the one architecture that I would like to highlight in this webinar today are actually optically pumped semiconductor lasers. And as the name implies, they're optically pumped instead of electronically pumped. At the heart, there's still a semiconductor laser. So you have your semiconductor epi layers that other semiconductor lasers also have. And so in these layers, you have quantum wells, and instead of having it energized electrically, you shine a pump light onto this stack, and the pump light is absorbed in this semiconductor layer. And then you have actually an external mirror to make the cavity. And having this external mirror then obviously allows you to do some fine tuning on wavelengths and so on. And the whole thing looks something like this here on the right-hand side, where you have your chip on a heatsink, and then the pump comes in at an angle, which is kind of convenient. And you can even have a nonlinear crystal inside to do frequency doubling or frequency tripling. And the biggest differentiator perhaps between this type of architecture and a standard semiconductor laser is the power levels that you can achieve. These lasers range from about 920 to 1180 nanometers. That's the native wavelength. And then, of course, you can frequency double intercavity, frequency double, or you can frequency triple, and that allows you to reach some other wavelength ranges. We're actually working right now on expanding the native wavelength range, as you can see here in the shaded area. We're looking to access down to about 700 nanometers. And then, of course, when you frequency double and frequency triple, that then fills out kind of the spectral range between the UV and the IR. And perhaps the most well-known implementation of this type of technology is actually the Verdi. Some of you guys might be familiar with the Verdi laser. It's been around for a number of years. I remember buying one in 1995 as a graduate student to pump a TISAF, and people are still buying Verdis to pump TISAF. Those have been around for quite some time and are really industry proven. So in summary, Coherent has been serving the quantum community for a number of decades, both on the scientific side, but as well also now on the more commercial side, where companies that are engaged in quantum technologies are purchasing laser systems from us. We have, fortunately, a relatively broad range of different technologies that we can leverage in order to build specific lasers. And we would love to engage with customers on your opportunities and hopefully help you go to scale and reduce the size, reduce cost, and leverage reliability. And with that, I would like to thank you for your attention.
So Coherent actually has been providing laser sources for quantum research markets for a long time, right?
That's correct. Obviously, predominantly it has been in the scientific sector, but now we're also providing these sources to some of the commercial entities. Now, there are not a lot of products out there, as we all know, that are in the quantum technology, but there's quite a few numbers of companies that have fantastic funding and are really on a great path for either quantum computing or quantum sensing or clock technologies.
Right. And so a couple of things that came to mind as you were speaking. One thing would be, so you sort of answered my second question, but when you talked about your optically pumped lasers, maybe go back to that just for a second. I think a lot of people might find this interesting. I mean, I, for example, did not know you were doing optically pumped semiconductor lasers. You talked about having power scalability, and power is in the quantum, laser ecosystem for enabling quantum. In many applications, power becomes a major issue, right?
That's right.
And so, without going, we're not going to try to boil the ocean here on this question, but, what kind of power levels do you think you can achieve in some of the interesting wavelengths that keep coming up where, customers need more power? I think a lot of people might want to know that.
So on the more common wavelengths that we've been working on for quite some time, we're on the tens of watts that we can achieve even at the harmonics. So for example, the Verdi is in that range where the fundamental is close to 50 watts or so. On the more exotic wavelength where we have to tune the semiconductor material, we're probably more in the couple watt range, but there are ways of scaling power. And it's really about understanding the epi that you're doing for the semiconductor. And we do the epi ourselves. So we're in a position to refine these systems depending on a specific wavelength and then scale up the power. So I would say in most wavelengths, just below a watt or several watts is certainly feasible.
Are any of those going to be in small swap packages, or is it all going to be Verdi size?
It's a very good question. So I had to make a trade-off here. So should I show the Verdi picture of a laser that everybody knows, or should I show the small package? Actually, these packages can be quite small.
Okay, so smaller than right. So sorry to cut you off, but we got to move to the next presentation. But I think the important point here, the takeaway point is, people in the webinar here or customers, they should definitely inquire with you if they have some of these requirements, right?
Would be great. Thank you.
Okay, sure.